and in this video we are going to see about conservation of laws. Generally, what is meant by conservation in physics? In the main, it remains constant, it is not varied with respect to any factors, any physical quantity. So, that quantity we are saying that conserved quantity. Understand? Any physical quantity that remains constant with respect to time or some other physical quantity, then we are saying that quantity is called conserved quantity. In physics part, we have 4 different conservation of laws. Yes, you all know well, but you didn't know about this is law of conservation of energy. As you know, the equation E is equal to mc square, right? The energy can be created or not, neither be created nor destroyed, or it can be changed into one form of energy into other form of energy, law of conservation of energy. And law of conservation of linear momentum. What is called momentum? Momentum P is equal to the product of mass into velocity, right? So, the mass into velocity, that will gives momentum. Linear momentum in the sense it goes in a straight line. And the third one, the law of conservation of angular momentum. What is called angular momentum? Yes, the object is moving in circular orbit or elliptical orbit, is moving with the one of the center as spoke here, right? So, that is called law of conservation of angular momentum, and later you will going to study the angular momentum is equal to moment of inertia into omega. What is called omega? Yeah, let me see. And the fourth one is law of conservation of charge. As any radioactivity, the law of conservation of charge takes place, and sometimes it may give some amount of energy, right? Now we move on to conservation of laws. In any physical process involving the different forces, some physical quantity remains unchanged. Remains unchanged means it is constant. Okay. With time, such quantity are called conserved quantity. Such quantity is called conserved quantity, right? And there are 4 different types of law of conservation of energy. Law of conservation of energy states about the energy can be neither created, here I miss created, nor destroyed. It can be changed one form to another form, right? So, here you should write energy can neither created nor destroyed, it can change from one form to another form, that is called law of conservation of energy. Do you know any very good example for law of conservation of energy? Yeah, of course. If you switch on the power supply, the electrical energy is converted into light energy. The energy is transformed into one form of energy into other form of energy. And an apple is falling down from the tree. Its potential energy is changed over into kinetic energy. Obviously, the total energy remains constant. That is called law of conservation of energy. And law of conservation of linear momentum. So, what is linear momentum? The momentum takes place in a straight path, straight line. So, no external force acts on a system, then its linear momentum remains constant. Any very good example? Yeah, if you are firing a rifle, okay, if we are going to firing with the help of rifle. So, before firing, its momentum is conserved 0, right? After triggering a rifle, what will happen? The bullet go in the front direction, right, and the rifle will go in the backward direction. So, that equal velocity is gains in the both side, bullet as well as rifle will go back. Yes, that time the linear momentum remains constant, the velocity remains constant, the rifle as well as the bullet, right. That is why the rifle go back after rifle, yes, and that is called law of conservation of linear momentum. And Law of conservation of angular momentum. What is angular momentum? Again I am asking. The angular momentum is equal to moment of inertia into angular speed. Moment of inertia I, angular speed is omega. The angular momentum can be expressed, or you can use a symbol as L. L is equal to I omega. So, no torque. Why we are saying torque now? Torque because it is acting in rotating systems, right? That is why we are saying instead of force we are using no torque acts on a system, then its angular momentum remains constant. Imagine the planets are revolving around the sun. Yes, when the planets approaches towards the sun, what will happen? The moment of inertia, of course, with respect to sun, the moment of inertia get reduces, therefore the angular speed get increases. Again I am telling, when the planets are revolving around the sun, the planets approaches towards the sun, yes, the moment of inertia get reduces with respect to sun, and to conserve the angular momentum, what will happen? The angular speed will be increases, right? That is very good example for law of conservation of angular momentum. And law of conservation of charge, yes, all the nuclear fission reactions takes place here. The total charge of an isolated system remains constant. What is called isolated system? When there is no force acting on the system, then that system is called isolated systems. So, here we have very good example. One slow neutron is going to bombard with uranium 23592, right, which gives barium 14156 plus krypton 3692 plus 3 slow neutron plus energy. So, here we have 92, right, and in this side you add 56 plus 36, that will give 92, and here we have 141, here we have 92, here we have 1, but we have 3 neutrons, 3 plus 92, 95, 95 plus 141, 3, 4, yes, 93, yes, we will have it reaches 235 plus 1, this side will gives 236, therefore the charges is conserved in these reactions. Yes, I hope you understand well. Thank you. See you in the next video.